Okay, so this is actually the answer to number 3. Let's go back and look at 1 and 2. 1 and 2, you didn't have to do anything. You just had to read off the paper. What is the probability that if 1 is selected at random, the probability that they're involved in a fatal accident? So it would be 3 out of the 8 million. Number 2, you were just supposed to read the distribution that they had already graphed for you there, the probability distribution that was already graphed. So, reading off that graph, 4 fatal accidents had a probability of 0.178. Part B, 10 fatal accidents had a probability of 0.001. And C, between 1 and 5 inclusive means we had to add from 1 all the way up to 5, including those. And when we find the sum of all those, we should have gotten 0.854. How'd you do? Okay, so number 3 is this chart shown here. It gave us an overload on our calculator if we tried to do it using the binomial PDF. But there it is. I used Excel and then made it graph it for me. Now, if we're to describe, I just read out all the answers for the back of the page and nobody said anything.
Oh, I thought you were
You skipped to the back of the page?
Yeah.
Okay, we'll finish going over the back of the page then.
Wait, what are you talking about?
Yeah, I'm reading the answers for the back of the page.
That's alright. It's good.
Yeah. Okay, so here's the graph that goes with the back of the page. And here's your probability distribution that goes with the back of the page. So, what I did was, I said, okay, it's out of 8 million. And then combinations of that, choose that, times the probability of success to the number of successes, the probability of failures to the number of failures, and then did the product of all those. And that's how I got my distribution.
Wow, that's very confusing how you put
Wait,
that
so,
in.
okay.
Really? That's not confusing?
I just want to write. I want to write down the steps. Can you just say the steps
Sure.
for making each list?
Sure.
All right. Let's go.
Here we go. Let's go. All right. What did I do? This is my total N here. Okay? This is my number of successes here. So what I did here is I did the combinations of N choose X. That's what this row comes from. And then here I did the probability of success, whatever that probability is, raised to the number of successes, and the probability of failure raised to the rest of them, N minus
Oh,
X.
so exactly what we did, just you put it
Yeah.
all put it.
And so then right here I did C, the probability of success to the X, times the probability of failure to the N minus X. That's what this column was.
That's not what I got, like big numbers for some of them.
On the back?
Yeah. Like I got.
Well, the sum of the probabilities can only add up to 1. So if I added up all those, the sum of the probabilities.
I got 1. I got 6.4, 20. I don't know. I just.
Woo!
Yeah. And it goes all the way up to 438.
All right. Well, I'll put this answer key on my website if you're interested in looking at it later.
Yeah.
All right.
And then there's.
Are you recording?
I am recording now. I wasn't earlier. Okay, so for some reason I decided to go over the back first. We'll go over the front in just a moment.
What exactly is going to be a quiz tomorrow?
I have a review sheet that goes back over everything. Your quiz is over discrete and continuous random variables, discrete probability distributions, and binomial distributions.
Oh my.
It's not hard.
Yeah,
The words in this section are more confusing than the actual math. Yeah. Me telling you what's on it is much harder than actually looking at the problems and doing it. All right. So now let's take a look at this graph. So then I made Excel graph it for me. There it is. So that's a nice, pretty. If you had to describe this, what would you call it? Slightly skewed left.
Symmetric.
Somewhat symmetric. Slightly skewed left. Yeah, that's what I would say too. I do see the tail to the left a little bit there. And it does look somewhat symmetric there. Okay. So that's what that graph looks like. Now, let's finish up the back while we're still on the back. So there's my chart for number 3. And I found the binomial distribution. That's what we looked at above. Number 4, is a binomial distribution a good model? How many of you said yes? Yeah, we're on the same wavelength.
Okay.
Yes, it is, because there are only 2 possible outcomes, and the events are independent. So a binomial distribution is a good model for this.
Yay.
All right, now, number 5. Honestly, I didn't expect fabulous things for number 5, but does anybody have an answer they would like to share with their peers that they're proud of?
I'll go for it.
All right, go ahead, Anthony.
Does it have to be in sentence form?
No.
Does it have to make sense?
Does it have to be in sentence form?
Oh, no. No, it does not have to be in sentence form.
Alright, so I took 8 million times 30, which is the number of years on there.
Okay.
Then I took 112 and divided it by that number. And then I got a number. And it probably doesn't mean anything, but I got a number and I wrote it down.
That is how it rolls.
Check it out. No, there's 30 years. I know, but you need to
Almost
function
fails
and scratch
plugging
it.
random numbers.
Thank you for sharing, Anthony.
You're welcome.
Yeah, I have some numbers too.
You guys record that? Yeah, give me on that video, YouTube. I'm gonna be YouTube famous.
He is going to be YouTube famous. He had an answer to that one, and he shared it with the class.
No problem. No one else was stepping up.
No, that's why I'm proud. That's why I'm proud. All right, let's go back to, I will not put a question like that one on your
I
test.
just said you would find a binomial distribution for 439
Okay.
years.
Okay, and then look at the probability for 1. Very good. That isn't a good way. Okay, so I've already shown you the answer on the front side. This was the answer to number 1. And when you plug those probabilities into your calculator the first time, it gave you an error message when you used the binomial PDF, correct? So we had to do these by hand. So this is the probability of 0 all the way up to the probability of 20. Our graph looks like this. So part B says, what is the least likely outcome? Well, the one that has the lowest probability is the least likely, which is the probability of 0 children, right? Okay, C, describe the binomial distribution. I would say skewed left because the tail over here. You might have said somewhat symmetric. I would agree with that too. Okay, D, we did not have to do. E, you could have done, especially if you already had data in your calculator. I got that the mean was this and the standard deviation was that, but I told you didn't have to do it, so you probably didn't. F, what is the probability that you will find at most 12 children watch professional football? So we'd have to add up from 0 to 12, right? Or we'd have to do 1 minus the probabilities from 13 added to 20, right? Okay, that's a pain, isn't it? Now, didn't we do something with our histograms that found that running total, that summed up everything before? What was it called?
E of X or something.
And cumulative. Cumulative. Okay, so let's go look at our calculator. We have a binomial CDF. Isn't that so mean how I always wait till after we've done it to show you the shortcut?
Yeah, it's pretty mean.
It is. I know. It is. All right, so here we go. We can find the cumulative frequency.
Appreciate that one.
I really meant to tell you yesterday.
That's a lie.
I did, but I was having one zinger of a Monday. Like first period, I was pretty sure I was going to have a heart attack. I even instructed my class on what to do when I started to pass out.
CPR and calling.
No, I told one of them to catch me so I don't bust my head open when I hit the con.
CPR certified.
Yeah. Are you? Excellent.
We just did it again.
I assigned somebody else to call the nurse. I didn't tell anybody to start CPR. That was dumb.
I am CPR certified 5 times.
Wow.
Call 911.
Okay.
30 chest compressions, 2 breaths.
You've been certified 5
Okay, so cumulative is going to add up to the number we tell it to. So on this one, we would want the cumulative, and we have 20 kids. We have 20 kids. Our chance of success is 0.72, and we want to add up all the way to 12. Boom! Isn't that nice?
Wow.
Yes. I used that at first instead of PDF.
That would've been,
Why?
All your answers were off.
But what numbers are you plugging in?
Okay, so 20 represents the number in our sample. We have 20 children. The 0.72 represents the probability of success, and the 12 represents how far we want to add up in our probability distribution. We want to do the sum of 0 to 12.
Same here.
Why do we not
All right, so are we good? We happy with the shortcut? And mad at Miss Willoughby for not sharing earlier. Okay, now on the last one, I went ahead and found the probability. Do you see how I did the combinations of 150 choose 95 times the probability of success and the probability of failure to those powers? And I got a probability that 95 out of the 150 would be 0.00478. So the probability of that occurring is 0.478%. Is that very likely?
No.
No, that is not very likely. So could you reject the findings? Yes. But as Ricky pointed out earlier,
Oh, no.
could we accept the findings? Yes. How could we accept the findings? We could just claim that one of these was an outlier and throw it out. So there is, be very wary of statistics because we can make statistics pretty much look any way we want them to. So always read, always read. All right, so your quiz is tomorrow. I'm passing out the review